Welcome to math class. We're continuing on in the MathWorks 10 workbook. We've moved on to chapter 5, which is angles and parallel lines. And we are starting off with 5.1, measuring, drawing, and estimating angles. So we're going to jump right into it. We'll start off on the example they have on page 15. And the first thing that we are going to be doing in this lesson today, actually let me extend my page here before I forget, is just looking at the different types of angles, and some of them have different names. So if you take a look on page 215, we have a series of drawings of different lines. So the first one we have looks something like that. We have one with a picture like that. I'm drawing too big for my screen already. We have D over here is, and then the last one, so the first thing we've got to realize is what they're referring to whenever we have drawings or shapes like this. So what we can see looking at our first one is we have two lines, and those two lines intersect at a perfectly right angle. The right angle is probably the most common and the most important version of this. You're going to see it anytime you're building a wall. This looks awfully similar to a lot of street patterns. Right angles are very, very important. So we kind of know what those look like. We have a straight angle over here. Sorry, I'm actually going to label these. So this is a right angle. Anytime you see a figure like this and it's got this little box on it right here, that means it's a right angle. It's a perfectly right, or sorry, it's a perfectly perpendicular angle. And this is exactly 90 degrees from here to here. Over here we have a straight angle. The degrees on this one is 180 degrees. This is very similar if you imagine you had a hinge on a doorway. So you've got a doorways that might close up to this position and then open all the way out to being straight or flush with the wall. So you need to be able to manipulate the different angles there if you're, say, perchance building a doorway. The next one we have over here, this is an obtuse angle. It is between 90 and 180 degrees. So it's bigger than a right triangle, but it is not quite a straight angle over here. The next one up, we have an acute angle. Acute means it is smaller than 90 degrees. Okay, so if we have our right angle over here, an acute angle is anything where our line goes up in the center like that, or even way over here, basically anything that's in between 0 and 90 degrees. And then our very last one is the reflex angle. This is more than 180 degrees. So we had, imagine for a second here that these ones are a little harder to explain on the screen, but we had, yeah, that's not going to help me. If we had two arrows and we dragged one and we spun it all the way around like this, you're getting a reflex angle. The best way that I can usually explain reflex angles actually goes back to snowboarding, mostly just because that's what I'm used to. But you'll hear oftentimes people talk about tossing 180s or 360s, or if you get lunatics who are really good, they'll start tossing 1080s and I think 1260s one. I gotta be not entirely sure, but I believe 1260 is a common one. So those are different versions of being able to do a spin in the air. 360 is all the way around. A 180 is basically just changing in the air so you're facing the other direction. A 1080 is actually 3 full turns in the air. Reflex angles are similar. They are obviously bigger than our straight angle up here, but they're not quite a closed 360. All right, so what they're going to be doing is they're going to give you some angle numbers, and you're basically just going to have to guess. Is it a right angle? Is it a straight angle, acute, obtuse, reflex, so on and so forth. Not overly difficult. You guys should be able to give that one a shot. So I'm going to skip ahead to the example on page 216. So next up, the next skill they want you to do is working on our guesstimating skills by understanding what our common angles would be. So we're going to be starting by looking at a perfect, I wonder if I have a, this will help, sort of. Yeah, I'll make one of these. So a perfect right angle looks something like this. I wonder if my eraser will erase shapes. Nope, won't erase shapes. Now, I'm using a triangle just because it's the easiest way for me to draw a right angle. But imagine that I were to perfectly cut, this is not a very good line, I'm going to use my fancy tools instead. So imagine that I was somehow able to find a way to make this exactly dead center of my perfect right triangle. Well, I know that my right triangle is a 90-degree angle. Half of that is going to be 45 degrees. So if I see an angle that I think looks like it could be potentially about half of 90, then it's safe for me to say that something is approximately 45 degrees. This becomes super helpful when we're looking at different sized angles. Obviously, or sorry, not necessarily obviously, we're starting off with looking at the different, what they call them in the textbook, reference, but the common ways that you might split a 90-degree angle. So the first one we had, obviously, this is going to be 45 degrees, but we could, let's make this one green. We could make another line that is, let's say, about a third of the way up instead of half. Ooh. Didn't like my color change here. Let's make this one green. Okay. So, or what if we take another line and I draw it about 2/3 of the way out of my right angle. Let's make that one red. All right. So what if I were to make that? Well, I know that this one would potentially be about 60 degrees. 2/3 of 90 is 60 degrees. 1/3 of 90 is about 30 degrees. So right off the bat here, I have 4 different angles that I can guess based off of just looking at a picture. So in the assignment, what they're going to do is they're going to give you something like this. They've got a straight line on the bottom, and then they'll have an angle somewhere in the middle. And basically what you're going to do is look at it in your mind. You could make a nice right triangle. Oh, that was not even close to touching. Let's try that again. So it's touching your axis point here. You get a right triangle. That would be about 45. That would be about 30. That's ugly. Maybe this is 60. So I would say that this particular black line right here is, we could even say, approximately 50 degrees or approximately 55 degrees, whichever one you think is closer based off of your guess. So go ahead and try those. Take a look at the examples they have in the textbook if you're confused about the other ones, but it's pretty straightforward. You should be able to handle those no problem. Oh, screen bounced. All right, so we're going to move on to the very last set of examples. where now we get away from guesstimating and they're actually looking at doing a little bit of quick math. So they're looking at complements and supplements. So a complement is where you're given an angle. Let me rewrite this somewhere. Okay. You're given an angle and you need to find out what else it's going to do, or what number you need to add up to make 90 degrees. Or you subtract the angle measure. I'm just going to use the one they had in the textbook, or the definition they had in the textbook, which is I need to subtract from 90 degrees, and supplements are to subtract from 180 degrees. So the question becomes, if I have an angle, so they give you some examples on the page there. So the first one they give us is 75 degrees. So if I have an angle that is 75 degrees, the question is, how much more do I need to get to 90? Or if I want to get to 180. So it's very simple. All I'm going to do here is 90 minus 75, and then over here I do 180 minus 75, and I find out that the complement to this angle is 15 degrees, and the supplement to this angle is 105 degrees. Pretty simple and easy stuff. The trickiest part of this one is just remembering which word they want you to remember. Complement or supplement. Complement or supplement. Sorry, I'm apparently losing my pronunciation skills. So we'll look at the next example here. They give us 43 degrees. So I need to know what it is if I want to get to 90, and I need to know what is left if I want to get up to 180. So I'm going to minus 43 here. I'm going to minus 43 here. I'm going to preemptively extend my page a little bit so I'm not always bumping it. And I find out that for this one, my complement is 47 degrees and my supplement is 137 degrees. Pretty easy, pretty simple math. You should be able to handle these ones on your own. And then the very last example we're going to do, I just need to take a quick pause. Okay. I seem to have forgot to save the right copy of my Smartboard lesson here. So the last example we're doing is on page 221, and we are actually looking at compasses. I don't think I have a shape for this one, unfortunately. I don't have much. Not going to work. So we're just going to do this one old school. I have two lines that I'm going to stay. This is sort of my average compass. Now most people have seen a compass. North, west, east. I'm going to slide this out of the way, and south over here. Well, let's for a second imagine that we've now put degrees onto our compass. So if we draw our lines here, what we could say is that north is a 90-degree bearing off of a straight line. I could say that west would then be a 180-degree bearing. The example they give on page 221 down at the bottom is the example of a boat that's heading southwest. So I'm going to delete this, put this back up. I need to not look at my books sideways while I'm making these videos. So I had my bearing numbers backwards. I was wondering why the example in the book didn't line up with mine. So when we're looking at a compass, what we can say is that we would be able to essentially superimpose this shape. Let me include my south just for fun. I could superimpose this shape over top of any map and be able to figure out what bearing I'm using. Obviously, that's a very important skill if you're going to be doing any sort of traveling on boats in the open ocean. Search and rescue uses this kind of stuff all the time. So what they basically say is that heading directly north is a bearing of 0 degrees. So if you were on a spot on the map and your target, wherever you had to get to go, was directly north of you, you would have to walk on what they say is the 0 degrees bearing, or directly north. If you had to go to the east, they would call this a 90 degree bearing. So the example they have in the textbook is they say that there's a boat that's traveling directly southwest. And what they want to know is, what is the true bearing? So if I were to pick this up and plop this on the map, what is the true bearing of this? Well, I start from my northern arm, or from 0 degrees. I travel it around, and I know that it looks as if it's exactly, or I guess I should say that southwest is exactly halfway in between south and west, which means that it's going to be a 45-degree angle, and it is 45 degrees past 180. So I have 180 degrees here. I have 45 degrees right there. That gives me an angle of 225 degrees as a true bearing. So they're going to be putting a few different examples in there of you, or for you, sorry, for you to be looking at bearing and looking at how this degrees can actually have a real impact on how people travel. So sorry about the confusion there. Next time I won't be reading my book sideways, but unfortunately this is what happens when I don't have access to a lot of video editing skills, essentially. All right, I will see you in class.